Chapter 1, Lesson 3, Scientific Inquiry. What is scientific inquiry? How do you design and conduct an experiment? What are scientific theories and laws? My Planet Diary. The law of falling objects. Misconception. Heavier objects fall faster than lighter ones. This assumption is not true. They actually fall at the same rate or with the same acceleration. The misconception was introduced by a philosopher named Aristotle and accepted for more than 2,000 years. But in the late 1500s, Galileo Galilei discovered something different. All free-falling objects fall with the same acceleration. To prove this, Galileo performed a number of experiments. Galileo's experiment involved rolling balls with different masses down a ramp called an inclined plane and making careful measurements. In the picture below is one of Galileo and one of his acceleration experiments. Now, misconceptions. Communicate. Discuss the following questions with a partner. Write your answers below. Why did Galileo perform experiments to see if all objects fall with the same acceleration? Number 2. Do you think a feather and a book that are dropped from the same height at the same time will hit the ground at the same time? Explain your answer in the terms of Galileo's discovery. What is scientific inquiry? Chirp, chirp, chirp. It's one of the hottest nights of the summer and your bedroom windows are wide open. On most nights, the quiet chirping of crickets gently lulls you to sleep, but not tonight. The noise from the crickets is almost deafening. Why do all the crickets in your neighborhood seem determined to keep you awake tonight? You're thinking and questioning, is this the start of a scientific inquiry process? Scientific inquiry refers to the diverse ways in which scientists study the natural world and propose explanations based on the evidence they gather. Some scientists run experiments in labs, but some cannot. For example, geologists use observations of rock layers to draw inferences about how Earth has changed over time. Posing questions. Scientific inquiry often begins with a question about an observation. Your observation about the frequent chirping may lead you to ask the question, why are the crickets chirping so much tonight? Questions come from your experiences, observations, and inferences. Curiosity plays a role too. Because others may have asked similar questions, you should do research to find what information is already known about the topic before you go on with your investigation. Look at Figure 1 to pose a scientific question about your observation. Figure 1, posing a question. The photo at the right is of a Roslyn's bush cricket from England, or Rosel's bush cricket. Make an observation about the cricket, then pose a question about this observation that you can study. Developing a hypothesis. How could you answer your question about chirping crickets? In trying to answer the question, you develop a hypothesis. A hypothesis is a possible answer to a scientific question. You may suspect that the hot temperature affects the chirping. Your hypothesis would be that cricket chirping increases as a result of warmer air temperatures. Use Figure 2 to practice developing a hypothesis. A hypothesis is not a fact. In science, a fact is an observation that has been confirmed repeatedly. For example, that a cricket rubs its forelegs together to make the chirping noise is a fact. A hypothesis, on the other hand, is one possible answer to a question. For example, perhaps the cricket only seemed to be chirping more that night because there were fewer other sounds than usual. In science, a hypothesis must be testable. Researchers must be able to carry out an investigation and gather evidence that will either support or disprove the hypothesis. Disproven hypotheses will still be useful because they can lead to further investigation. Developing a hypothesis. Develop a hypothesis. Write 2 hypotheses that might answer the student's question. Hypothesis A, fill one out there, and hypothesis B, fill one out there. How do you design and conduct an experiment? After developing your hypothesis, you are ready to test it by designing an experiment. An experiment must follow sound scientific principle for its results to be valid. You know your experiment will involve counting cricket chirps at warm temperatures, but how will you know how often a cricket would chirp at low temperatures? You cannot. know unless you've counted other cricket chirps at lower temperatures for comparison. Controlling variables. To test your hypotheses, you will observe crickets at different air temperatures. All other variables or factors that can change in an experiment must be the same. This includes variables such as food, the hours of daylight, and the hours of daylight. By keeping these variables the same, you will know that any difference in cricket chirping is due to temperature alone. The one variable that is purposely changed to test a hypothesis is called the manipulated variable or independent variable. The manipulated variable here is air temperature. The factor that may change in response to the manipulated variable is the responding variable or the dependent variable. The responding variables here are the number of cricket chirps. The bottom, apply it. A student performs an experiment to determine whether 1 gram of sugar or 1 gram of salt dissolves more quickly in water. Number 1, controlled variables. Identify the manipulated variable and the responding variable. Number 2, identify what are 2 other variables in this experiment. Number 3, draw conclusions. Write a hypothesis for this experiment.